Second part, the block diagram. The block diagram, it is an easiest way to represent the output signal and input signal in the transfer function. Transfer function is the big letters with the, I actually did not write down the Laplace domain, but it is of course in the Laplace domain. So I'm going to show you, this is from the Ogata book, which is chapter 10, I believe. So I'll share with you these slides first. So let me, I'm sorry, this is already been. So let's do this. I want to know this is my output, okay? This is my input. So my plant is G1 and this is a feedback system. So let's do this. Before I teach you this one, I want to show you something, the block diagram algebra from our Ogata book. This is a table which tells us that how the signal comes into the transfer function. Signal are the arrows, and if you, this is not a clean picture, let me pull up the clean picture from Ogata book. So if you, yes, this is our Ogata book. I think this is table 10.1. Yes, this is table 10.1. So let's copy and paste in our notebook here. See if it is, yeah, this is much better. So let me, so this on the left hand side and on the right hand side equivalent block diagram. So let's see if the signal goes into this summation block. This is signal B. Before I tell you that, so how would it happen? So we know that this is the signal coming in, this is a signal coming out. So for example, A goes in, B comes out. So the transfer function is output over input. So you can also write down as like what is B? B is equal to G times A. So that's what it is written here. B is like G times A or A times G, and then there is a summation block. Usually the feedback signal is negative in the usual cases, but it could be positive. That you see, this is negative, but sometimes it could be positive, but most of the time this is negative. So you should know how to find out the transfer function from the block diagram. And this is AG, and this wire has been just split up from the signal, so it is the same signal, A times G. This is the same signal, A times G, and this wire has been added and branched off from of the main wire signal. So A is the signal coming out. So let's do this. How would you find out the equivalence B over A for this case? So let's do this. What I would do, this is the error. So error. So let me start from this diagram which I explained here. Did I explain you here? I think I can do this very quickly. Yes, over here. So let's do this. So what is E? E is the error, which is the feedback signal, which is B of S or B, and so I can write down E is equal to, if the summation block, so R goes in with a positive sign, so R is positive, negative B, and we are interested in C over R. And what is B? B is output, which is equal to G2 or CG2. C, G2. So we are interested in C over R. So E is equal to, what is R minus B? So R minus CG2. This is my E. And what is C? G1 or EG1. Because if you take a look, this C is G1 times E. So I can write it down over here. EG1. So let me go back here to see if I'm not doing any mistakes here. Yes, this is the same thing. And then I'm going to copy paste here and just plug it in over here. I wrote it down like E, G1, G2. So this has been written here. So C is equal to G1 times E. This is my E. This whole bracket is E. And then B is equal to G2C. And then, so what is my C over R? C over R is G1 over 1 plus G1 G2. This is how you complete the transfer function from the block diagram. So let me go back over here. If you take a look at here, this is the equivalent block diagram on the right hand side from the left hand side. So this is, so you see we have the same answer. So this is how you find out the transfer function from the block diagram. Okay, thank you guys.